Okay, this week we're going to be dealing with similar figures. We're also going to be dealing with scale drawings, but that'll be in the next video. So let's deal with the first question. We talked yesterday about the definitions of corresponding angles and sides, something being congruent and something being similar. Remember, congruent it just means that it is exactly the same as something else. The side angles are the same, or the angles are the same, the side lengths are the same, and all this. Similar just means it has the same shape. And a great example of that is a globe and the earth. The exact same shape, but not exactly the same size. And we can do this problem right here the same way when we're talking about a shadow at the same time of day. So we have a gate that's 3 feet tall. We have a gate that's 3 feet tall and it casts a 5-foot shadow. And then we have a building that casts a 45-foot shadow. And we don't know how tall it is. It's asking us to figure out how tall this guy is. Okay? Well, all we need to do is label a proportion and go from there. So let's say height over the shadow. And we could have put shadow over the height if we wanted to. As long as we're consistent throughout the problem, it doesn't matter. And we'll start with this one first. We'll start with the gate. That's 3 feet over 5 feet. And then we have x feet over 45. Now all we need to do is cross multiply and set everything equal. Okay? So we would have 3 times 45, and I'll do that up here. 45 times 3. And that's going to come out to 135. When we cross multiply, forgive my writing. And then of course 5 times x is 5x. And we set that equal to 135. Then of course we divide both sides by 5. This cancels out. 135 divided by 5 is going to equal 27. And of course 135 would go in the box. Therefore the building itself is 27 feet tall. Okay. Tell if these shapes are congruent or similar or both. Remember, congruent means exactly the same. So we can look at these guys and tell that they are not exactly the same because we had a width here. This was 4.5 centimeters and this one's 6. Well, we need to also check to see if they're similar. So we know that they're not congruent, but they could be similar. The two things that must be the case for them to be similar is the corresponding angles must be the same. The corresponding angles, not every angle, but the corresponding angles, and the measurements here must be proportional. Well, this angle goes with this angle. This angle goes with this angle. This angle will go with this angle, and this angle will go with this angle. Now, luckily for us, this is laid out perfectly for us, and we really don't have to do any guesswork. Sometimes you're going to have to really do a little bit of work to figure out what angle goes with what. In other words, which angle corresponds with another one. Now, the good news again here for us is these are rectangles, it looks like, and they're all right angles. Therefore, they all are the same. So all of the corresponding angles are equal. So one requirement of something being similar is met. Okay, all the corresponding angles are equal. Now we just have to figure out if the side lengths are proportional. So why don't we just go ahead and do, let's do width over height this time. And again, we could have done height over width. It really doesn't matter. But as long as you're consistent throughout the problem, and you know you're going to come up with two fractions. And let's deal with this one first. What's the width? It's 6 centimeters. The height is 4 centimeters. The width of this one is 4.5 or 4.5. Here's 3. Now all we need to do is cross multiply, and if we get the same answer twice, then it is proportional, and therefore we do have similar shapes. Another thing we could do here if we want to, and then remember, every time I want you to set up a proportion, come up with a and cross multiply. On the other ones, like the one we had before where we had to cross multiply and come up with a one-step equation, I want to see that work because I need to know that you can A, set up a proportion properly, that you can cross multiply properly, and that you can come up with a one-step equation properly and solve for it. Because those will be skills that you must know next year. Now, as I've always told you, reduce early and reduce often. If you want to reduce this, you can. You do not have to, but you can if you like. So you can reduce, this will reduce down to 3/2. Remember, you don't have to do that, but it makes it a lot easier to deal with the numbers. So, 3 times 3 equals 9. 2 times 4.5, and I'll just do it out over here, but it is going to equal 9. So we have 9/9, therefore it is proportional. And because it is proportional, and because the corresponding angles are the same, it is similar. Now, if you had left this 6/4, you would have multiplied that out and got 18/18. Does it matter if it's 9/9 or 18/18? Absolutely not. As long as you get the same answer, in other words, as long as you get 1 here, or the same number over the same number, you're golden. Paula casts a shadow 2 meters long. So this is Paula. Then the shadow here is 2 meters long. At the same time, the tree casts a shadow 28 meters long. The tree is 17.5 meters tall. How tall is Paula? We're going to put an X in over here. Okay? So we're going to do, again, height over the shadow. We're going to do X over 2 for Paula. Then we're going to do 17.5 over 28. And we're simply going to cross multiply again. And I want to see your work every time. This is going to end up being 28x equals 17.5, just take my word for it, times 2 is 35. You can divide both sides by 28. This is going to cancel out. You're going to have 35 in the house over here, divided by 28. Go ahead and put us some decimals over here and bring it up. This will go in here once. 28. Left over 7. Bring down my 0 here. This is going to go in here, it's like twice. That's 56. With a remainder of 14. Bring down my 0. You may have to try it this one a few times, but this is going to go in here 5 times. She is 1.25 meters tall. And that's all you do on all of these. Take your time, and I've done it kind of quickly here for the sake of time, but you need to take your time and multiply these guys out. You guys should be able to multiply 17.5 times 2, get 35, and do all this work. I want to see a one-step equation for every time you have to solve for x or whatever variable you choose. I want to see that you've come up with a one-step equation. In the diagram below, triangle, and this is how we say, this is how it's written down, triangle. You'll see a little bit of triangle in ABC. If we're talking about the angle, we would say something like angle T for this right here. But anyway, in the diagram below, triangle ABC is similar to RST. Now there are a couple things I need you to understand about this. If we tell you that they are similar, you need to assume that they are. You need to assume that all corresponding angles are the same and that the side lengths are proportional. Now here's one thing I need you to make sure you understand. This is very important. ABC, triangle ABC. A comes first in the alphabet, obviously. Okay? When you're looking at another triangle, RST, R comes first in the alphabet of those three. Therefore, it corresponds with A. Now you're thinking to yourself, well, Mr. Kemp, I can tell that that's obvious. The way the shapes are, the way they're both laid out, it's easy to tell. Well, every now and again, you're going to get a problem like this. You're going to get a crazy looking triangle, and you're going to have another one that's over on its side like this. And this was going to be A, B, C. Excuse me. And this one will be X, Y. Oh, sorry, Y and Z. And you're going to have to know the order of them. A comes first in the alphabet. X comes first in the alphabet of these three. Therefore, these two correspond. So sometimes they're going to try to confuse you. It's not always going to be laid out exactly this way. Okay. So, if the measure of angle A, and that's how we say angle A, that's how we show it, which is right here, if it's 40 degrees, then which angle must also measure 40 degrees? It's angle R, and we would write that like so. If the length of RT, and I don't like how they've done that here, that should be RT with a line over it. If the length of RT is 12 centimeters, RT is 12 centimeters, then what must be the length of AC? Those do correspond because you're going from the first to the last letter in the alphabet in that triangle. Here we're going from the first to the last. And again, it won't always be laid out this easy. But what they're saying is, this corresponds with this right here. And if RT is 12, then what must this be? And we will say x over 2 and 12 over 6. Again, you can go ahead and cross multiply now and come up with a one-step equation, or you can reduce this. I'd reduce it to x over 2 and 2 over 1. That makes things a lot more simple. So I'm going to say 2 times 2 is 4. X times 1 is just x equals 4. Or if you did it the other way, it would come out with the same answer. You would have, here you would have 6x equals 24. Okay? Here, I'll move that down a little bit for you. Divide both sides by 6. 24 divided by 6 is 4. And it would be centimeters. So we want to make sure we put the unit there. All right. If triangle CDE is similar to triangle XYZ, what is the length of XY? Well, this is similar, not congruent. Remember, if it were congruent, it would be exactly the same, and therefore this would be 96 centimeters. But we're saying similar, not congruent, but similar. Okay. C comes first in the alphabet. X comes first in the alphabet here, so these correspond to each other. Again, visually you can tell that, but it's not always going to be that easy. So it's asking you, what is the length of X and Y? Well, C goes to D, X goes to Y in the alphabet. Therefore, these two side links are going to correspond, and we don't know what that one is. So again, we're going to set up a proportion. We're going to say height over width. We'll start with this one first. 96 over 40. X over 30. Again, you can reduce this if you want to. I'm not going to this time because I'm going to do a little bit of a practice session with some multiplication here. So we're going to have 40x equals 96 times 30. So we're going to say 96 times 30. 0, 0, 0. 18, carry my 1, 28. For a total of 2,880. I'm going to divide both sides by 40. This is a skill that you have to learn, the one-step equation. This is gone, those cancel out. Now you're going to have 2,880 divided by 40. Excuse me. 4 will go into 2. It won't go in. It won't go into 28, but it will go into 288 about, looks like about 7 times. Let's try that. 280. Yeah. I'll lift over with 8. Bring down my 0. This will go in here twice. Therefore, this is 72 centimeters. Okay. A house that is 16 feet tall casts a shadow. I'm not going to do this one again. We've done a couple like these. If you need more help with that, go back and look at the other ones. I'm not going to do number 9 because that's exactly the same as the cast shadows we've done before. Look at the parallelograms below. All are parallelograms A, B, C, and D, and I, J, K, and L. Are they similar? Explain your answer. Well, the two things that must be the case is that you must have corresponding angles that are exactly the same. A comes first in the alphabet, A, B, C, D, so we're going like this. A, B, C, D, E, F, G, H, I, J, K, L. All right, so these are perfectly set up for us. The angles are the same. The angles are the same. Now, this is where this is going to start to confuse people if you're not careful. Are they proportional? 17 millimeters, 25 millimeters. 17 millimeters, 25 millimeters. 17, 25, 17, 25. Now, are they similar? Actually, yes, they are, because by definition, these are congruent because the side lengths are the same. Because the side lengths are the same. But they are also similar. And I'll tell you exactly why. If you multiply 17 times 25 and then 25 times 17, you're going to get the same answer. So, what I'm trying to make you understand, or make sure you understand, is that all congruent shapes are also similar. But not all similar shapes are congruent. A good example of that is a similar shape, a globe, which is about, at the most a foot wide, 1.5 feet wide, isn't exactly the same size as the Earth. It is similar, but it's not congruent. And so these are, yes, they are similar. Could parallelograms A, B, C, and E, F, G, H be similar? Explain your answer. We don't know about the angles, but let's just assume that they were. Let's just assume that this was 130, and this was 50, and this is 130, and this is 50. Let's even just go ahead and go out on a limb and say that those were the same. Are they proportional? Is 17, and I'll do the work down here, 17 over 25 proportional to 25 over 30. Well, I can reduce this to, what is that, 5 over 6. So let's multiply that guy out, and I'm going to use a calculator for the sake of time. 17 times 6, this is 102, and 5 times 25 is 125. Is that proportional? No. Therefore, they are not similar.